Alright, this is lesson 59 for Algebra 2, simplifying and evaluating log expressions. So we talked about logs yesterday, which are the inverses of exponents or exponential equations. So we use them in math to do mathematical modeling. And so we need to know how to evaluate them. And so we'll be reflecting or really going back to using exponents today a lot in those terms. These are the steps for today, and I'll show you a couple of them, alright? So, first, and then we'll work it out. Numbers 1 and 2, we have number 1, evaluate each expression. Whenever we see the word evaluate, it just says, what is the answer here? What does all of this become? What is that, the answer? Okay, so the first thing you want to do is, whenever I see this as a math student or just a mathematician, I'm just going to set it equal to x. I'm asking myself, what is all this equal to? That's the unknown. Okay, we need to solve for that. I like thinking in terms of exponents. So this is like saying 2 to the x is equal to 4. And right now I could do this in my head, right? The answer is going to be 2 clearly, but I want to show you the method that you need to follow. Okay, the way you need to solve this is you need to find a common base on both sides. I know that 4 is just like saying 2 to the second power. And on the left side we still have 2 to the x. Since I now have a common base on both sides, 2 and 2, I could just assume that my exponents are equal to each other, so x is equal to 2. That's your answer. Okay? So what did I just do? I set the expression equal to x. Then I rewrote the logarithmic equation as an exponential equation right here. Then I found a common base of 2. And once the bases are the same, I set the exponents equal to each other, x is equal to 2. Sometimes it won't be so easy like that. So, number 2, let's try another one. Very similar. It looks like a scary fraction there, but don't let it phase you out. First thing you do is set it equal to x. Then step 2, rewrite the logarithmic equation as an exponential equation. So we have 3 to the x is equal to 1/27th. The next thing we want to do is find a common base. I know 1/27th is just like saying 3 to the negative third power. So we have 3 to the x is equal to 3 to the negative third. We have the common base of 3, so I could assume my exponents are the same. So if x is equal to negative 3. Okay, x is equal to negative 3. So that's how we do solving logarithmic expressions, okay? Any questions? Yes. Negative 3 because 1/27th is like saying 1 over 3 to the third. Remember that? And then earlier this year I said this is the same thing as saying 3 to the negative third. Remember that? Because you could switch the exponent to the opposite side. Okay. All right. So what I'd like you to do is today's Thursday. Let's have 2 start talking about number 1. 1 talk about number 2, and then write these down. Ready, set, go. Okay. Number 3, we got log base 2 of 8. Okay. First step, everyone. What does the first step say up here on the board? Set. Good, set it equal to x, so we're all writing this down. Step 2. Let's read step 2 out loud. Rewrite. Everyone, what's step 2? As an exponential equation. Okay, so what should I write? I'm going to write 2 to the x is equal to 8. Okay. Do we have common bases on both sides? No, we don't. So what's a common base that I could have on both sides? 2. So 8 is like saying 2 to what power? 2 to the third power. So we got 2 to the x is the same as is equal to 2 to the third. Okay, are our bases the same now? Yep. So x is equal to 3. Now you could have done this in your head. I know that, but you need to practice the skill of converting a number with a common base, okay? So I want to see your answers. Let me see your answers. Make sure you're working. Okay. Check.
My iPad just turned on.
Okay, good. All right, number 4. Number 4. Tell me what to do now. No, what am I supposed to do first?
Set it equal to x.
Set it equal to x. Next. Tell me what to write.
3.
3.
3 to the x power
Uh-huh.
equals 243.
Good. Next, what am I supposed to do?
Find out the bases.
Okay, what's a common base I could use?
3. No.
3.
3.
Okay, so 243 is equal to what?
Wait, never mind. Just
3 to, so the way I do it is I do it on my fingers because I'm not very good at math to do it that quickly. So 3 to the first is 3, to the second is 9, to the third 3 times 9 is 27. 27 times 3 is 81. 81 times 3 is 243. So, yeah, it is times 3. Does that make sense? Again, so, and the clue is, let me show you what the clue is when you're doing your work. You're going to try to find the smaller base first and see if the other one fits in there. Okay? Okay, next step, x is what? Equal to, okay, I'm going to just stop it right here. I want you to finish the problem for me. It's a joke. Finish it. I want to see your iPads. Go. Continuing, number 5. I'll do this one, and then you'll be able to do number 6 by yourself, okay? So number 5, I'd still do the same thing. It's going to be this whole logarithm equal to x. Then I'm going to rewrite this as an exponential equation. We have 5 to the x is equal to 1/25. Okay, and I'm trying to find a common base. Now I know 25 is like 5 squared, so if I were to do a side problem, I'm thinking if 25 is equal to 5 squared, then I know that I can make this a negative exponent of 5 to the negative second, right? So I'm going to rewrite this as 5 to the x is equal to 5 to the negative second power. Okay? Again, finish this problem off. I'll look at your... Okay, and again, when you get good at this, you could do this one in your head, right? But the goal isn't just to do it in your head today. I want your goal to be, how do we convert these numbers with a common base like this? That's really your goal for today. That's why I'm having you do the extra step. Number 6, all the way through by yourself. You can use number 5 as a guide. Go. So number 6 again, this is like saying 4 to the x power is equal to 1/64. You know, 64 is like saying 4 times 4, which is 16, times 4 again is 64. Okay? So we got x is equal to negative 3. Okay? All right, next one. Number 7, we got log base 2 of negative 1/64. Okay, this is very similar to number 7 or number 6. Okay, so try to work this one out. Go. All right, so we got 2 to the x power is equal to negative 1/64. Raise your hand if you did that step right. Okay, that's good. Now let's think conceptually. Let's pretend that there was no 1/64th, but it just said negative any number. Okay. 2 to what power is going to ever equal to a negative number? What's 2 to the first? 2 to the second? 2 to the third? Is it ever going to turn into a negative? No, let's go negative. Okay, 2 to the negative first. No. 2 to the negative first is? 1/2. What's 2 to the negative first? Good. 2 to the negative second? 1/4. 2 to the negative third? Good. To the negative fourth. Okay, is it ever going to be a negative number? No. So when it's asking for a negative solution, we can't. You just can't do it, right? So it's undefined is your answer. Okay? I did get you. But I want you to see that. And here's your clue. You need to, don't just assume it's going to be undefined always whenever you have a negative, because your base could be negative. Okay? You just need to make sure when you see negatives that you're very careful to check if it's undefined. Number 8, go by yourself. Okay, look at this. 5 to the x power is equal to a negative 125. Can you ever have the base of positive 5 ever turn into a negative number? No. So it's going to be undefined again, okay? Some of you start putting 3 or negative 3. Wrong. Okay, so beware. I know that's a little tricky, but you can do it. Alright, that concludes this lesson. So what I'd like you to do is discuss these 4 questions with your neighbor.